Welcome back, Cal 1. 5/8 inverse trig functions. These are our three new rules that we should memorize, I guess. But anyway, and now we've got a beautiful list of antiderivative rules now. This really completes our list of antiderivative rules. And there's a nice summary of that in 5/8. There's a nice big chart of all our antiderivative rules. And U substitution is a technique that helps a lot. Anyway, so here's this problem. So, and this is in section 5/8. I just made this up, but it's similar to some homework problems you have. Anyway, which one do you think it is? I'm learning these three new rules. And anyway, I'll talk to you. I don't see a square root in the denominator, so I don't think it's those two. I do see this sum of an a squared and a u squared, so I think it's an arctangent. What's funny about that, though, is the arctangent should have some kind of number on top. Even if it was a 5, I could pull the 5 out front, but I have a function on top and e to the x on the numerator there, so it's throwing me off a little. But if I carry through the steps, you'll see what happens. Maybe you know what happens. So if I'm thinking that's an a squared, if a squared is 9, what's a? A is 3. Okay, cool. If this is my u squared, what I need to think of is that's an e to the x squared. That's what that e to the 2x is. It's an e to the x squared. So what's the u? U is e to the x. If that's u squared, u is e to the x. And I taught you last time, well, if you're calling something u, you better carry through the u substitution process. Du then is the derivative, which is e to the x dx. And when I start to try to replace this stuff, here I go. I'm replacing things. I'll turn it into u. What happens is, well, I'm not going to really replace this. That's my 9. That's my 9, which is my 3 squared, my a squared. But this becomes my u squared, right. That's my u squared. And this e to the x dx that I was worried about is wiped out. That's my du. So I could call that du, or I could put a 1 up there and call it du off to the side. That gets replaced with du. So this is a beautiful a squared plus u squared. There it is. This is arctangent. So here I go. The answer is 1 over a. Arctangent has a 1 over a. So does arcsecant. That arc sign doesn't have that. Okay. 1 over a, arctangent, u over a. I could put u over a. What was the u? Oh, there it is. E to the x over a, which was 3. Yeah, there's the answer. So that was a nice problem. Here's another one. I found this in the book. This is more challenging. I'm going to get rid of this one in case you want to pause and write it down. I got a more challenging one here. This actually came out of the book here, number 20. And it looks like this. It's an x squared plus 8 over an x times the square root of x squared minus 4 dx. That's a hell of an integral. So again, I'm sort of looking for the pattern, and I look at that denominator. That's my focus. I focus on that denominator, and it sure looks a lot like this arcsecant pattern, except the numerator sure doesn't. I need the numerator to be a number, a 1, a constant, or any constant would work. But that x squared plus 8 in the numerator throws this off big time. So you got to have an idea. Yeah, so I'll wait here for an hour waiting for your idea. No, I know what your idea is. Your idea is maybe I can bust this up. This numerator is 2 separate numerators added together with a common denominator. I could bust this into 2 different integrals. So if I write it as x squared over this denominator plus an 8 over this denominator and treat it as 2 separate integrals, I think I can do this a little easier. So that's the deal. You can separate that numerator over this common denominator and treat it as 2 separate integrals. And the first one is interesting. In the first integral, that x can cancel. So you can cancel that x away from that one of those x's. And so I'm left with this, 1x over the square root of x squared minus 4. And if I try to look for that pattern, that's not really here. And maybe I should recall that that's a classic good old u substitution problem. That's not one of these. I'm sorry. That's not one of these. This is let u equal the x squared minus 4. du is the derivative, 2x dx. This is classic old chapter 5 stuff, 5. I'm happy to get that x dx. Now I'm happy to kill that x dx. Let's see. I'll move the 2 over. 1/2 du equals x dx. So I'm rewriting this integral here. I'm going to go right here if you don't mind. The numerator just turned into 1/2. I'm pulling out in front of the integral. The numerator x dx just turned into 1/2 du. The denominator is the square root of u. Okay, I know how to do that. I'm going to move this way. You move it up, you do a power rule, that's 1/2. You move it up, u to the negative 1/2. When you move it up, I've done all this work. I haven't integrated yet. I still write the integral symbol, and I still write the du. Now I think I'll integrate. Add 1 to that. When you add 1 to that, you get u to the 1/2. You divide by 1/2 or multiply by 2, which cancels that. This problem's over. Plus c. Actually, that's going to have a plus c. I'm going to add my 2 answers and have 1 plus c. But this problem is over. It's the square root of u. That was cool. What is this? This looks a lot like good old arcsecant. And you know, I told you a few minutes ago, you know, that maybe what's the a? The a is a 2. The a is a 2. That's a squared. The a is a 2. And the u is just an x. Well, when the u is just an x, I don't need, the du is just a dx. It's not going to spit out a half. Nothing's interesting is going to happen. I think I'm ready to shout out this answer. This answer is arcsecant. Let's see, 1 over a, 1 over 2, arcsecant, u over 2, the absolute value of u, the absolute value of that x over 2. U over a plus c. Now there was something else going on. There was an 8 on top of this integral. There was an 8 that I pulled out front here, so there's a multiplied 8. That's the answer. It's added to this. If you don't mind, I'm going to just use the magic of a whiteboard. This is the square root of u. That was this u for this problem, plus c, but the plus c is going to join with that plus c. So here's the answer here. The answer here is the square root of this u, the square root of this x squared minus 4, plus this, I know you can, and there's the answer to this good problem, which we split into 2 problems. That's interesting. I like that problem. All right, there's a lot of good homework you can practice. There's another idea. Sometimes in order to fit the pattern, you have to complete the square. I might do another video about completing the square. And all right, thanks. Do some homework.